So how do you know when something has an inverse? Well, the inverse path must be I'm going to use the mathematical term well defined. So that if we know that x goes to y, there must be only one way to return y to x. The inverse path must be well defined so that if we know that x goes to y, there must be only one way to return y to x. So in other words, if I'm going from here to San Diego, there's only one way to return me from San Diego back here. There's no diversions. They're direct flights both ways. Well, which is usually the case anyway. So a function must be 1 to 1 to have an inverse. And this is where things get really kind of weird because when I was at ASU, when we hit this stuff, usually, well, in college algebra, when they got to it in college algebra, the teaching assistants who were helping and tutoring and that kind of stuff, there would be this argument every semester about this whole idea of 1 to 1. And this is the issue. We're talking about a 1 to 1 function. I need some space. And they say, well, I mean, that doesn't make any sense. Well, it does. A function goes from x to y. 1x to 1y. When I say a 1 to 1 function, that puts a stronger restriction on the function. This means 1y to 1x. A function is 1 to 1, but it's x to y. A 1 to 1 function is also 1 to 1 the other direction. That means it's y to x. So if x goes to y, y must go to x. A 1 to 1 function is very restrictive. And we use something in terms of the y to x thing called the horizontal line test. Remember the vertical line test when we tested for functions? Well, a 1 to 1 function has to pass a horizontal line test. You can see it in the pictures here. This is a function. The question is, does it have an inverse? Well, if I draw a horizontal line, we'll call it an HLT, horizontal line test. How many places does that intersect the graph? Well, just one. one horizontal line intersects in one place. And yes, there's an infinite number of horizontal lines, but one horizontal line, one place, one horizontal line, one place. Well, what does that mean? That means that it's 1 to 1. That means that there's only one x to one y. So this has an inverse. Now this guy, if I draw a horizontal line, what do you notice? It intersects in two places. This is a single y value. If I look, here is an x value, here is an x value. That means that x1 has the same y value as x2 does. That says if I start at y, does y go back to x1 or does it go back to x2? He doesn't know. He's confused. If I were to look at a map of this thing, so I know that x1 goes to y, x2 also goes to y. Now, I'm over in the range trying to find my way home. It's kind of like E.T. And then who do I call? Do I call x1 or do I call x2? Call home. I don't know what home is. Home is one of those two places. I don't know which one. It's kind of like, if you come home and you're really, really tired and you're basically almost falling asleep and you're in a neighborhood where all the houses look alike, which one is yours? I don't know. You end up someplace you don't want to be. And that's what the issue is. If it has an inverse, there is absolutely no, you're going to know where you're going to go to. And in this case, it does not have an inverse as it stands. However, if I were to just do this and say, I just want x greater than or equal to 0, does that have an inverse? Yeah, I can restrict the domain. We're going to talk a little bit about that when we get into inverses. But as it stands, it doesn't have an inverse. What about this guy? No. What about this guy? Yes. Passes the horizontal line test. Passes the horizontal line test. This guy fails the horizontal line test. Well, but see, if any place I draw a line, does it intersect in more than one place? So that says I pick a y value, it only has one x value.